Hello, today I'll be making various cobalt pyridine complexes. The first two are bis-Pyridine Cobalt Tetrafluoroborate and bis-Pyridine Cobalt Chloride. They are both fairly similar, so I'll combine some of the footage. For the first complex, I measured out 10 grams of Cobalt Tetrafluoroborate hexahydrate. And for the second, 10 grams of Cobalt Chloride hexahydrate. I dissolved both of them in anhydrous ethanol, and while dissolving, the cobalt loses 6 molecules of water and turns into this nice deep blue. We need to use ethanol for this very reason, as both of the complexes decompose in water, so an anhydrous solvent is needed. After that, I measured out the pyridine. For the tetrafluoroborate complex, I used 5 ml of it, and for the chloride complex, I used 8 ml. If you are planning to do this synthesis, proper ventilation is absolutely necessary, since pyridine has a very strong and irritating smell. I added the pyridine to the solution, but not much happens at first since it takes a bit of time for the complex to form, so I left it to stand and stir for a few hours. Coming back the next day, the first complex precipitated out as a very fine, light purple powder. I decanted it, transferred it to a crystallizing dish, and slowly dried it on the hot plate. And while drying, the complex redissolved into the small amount of hot ethanol left, and after drying completely, it turned into a blue powder. But after some time, the powder changed color back to the light purple. So what happened? To understand this, we'll first need to discuss molecule geometry. There are two main geometries we need to consider: tetrahedral and octahedral. This paper shows that the blue foam we saw in solution and after drying is a tetrahedral monomer, while the purple foam is an octahedral polymer. However, in our case, the complexes will have a different structure due to the inability of the anion to coordinate. Now, what I think happened is that the blue foam and purple foam are just different hydrates of the same compound. So the blue foam is a dihydrate and the purple foam is a tetrahydrate. And what I think happened is that as I was drying it, it lost some water, turned into the blue foam, and later in the vial it rehydrated back into the purple form. Now onto the second complex. The beginning is more of the same. I added the pyridine to the solution and let it stir for a few hours. After that, the complex precipitated out as blue, needle-like shiny crystals. I decanted it and transferred it to a crystallizing dish. However, this time the complex remained blue, even after weeks of sitting in a vial. The paper we discussed earlier mentions that the blue foam can be isolated from hot alcohol, as long as it's kept in anhydrous conditions. As for the third complex, trans-Dichlorotetrapyridinecobalt-free chloride, the preparation is a little bit more involved, since it requires the use of chlorine gas to oxidize cobalt 2+ to cobalt 3+, so do not attempt it without the proper PPE. I first measured out 20 grams of cobalt 2 chloride hexahydrate and dissolved it in 40 grams of water. The paper I'm following mentions that the amount of solvent needs to be somewhat precise. While that was dissolving, I prepared the chlorine generator. I measured out 50 grams of calcium hypochlorite and put it in a round bottom flask. After washing out the beaker, I measured out 170 grams of 30% hydrochloric acid. The exact amount of both of these doesn't really matter since I am using a large excess of chlorine gas. After all the cobalt chloride has dissolved, I added 30 grams of pyridine. I let it sit for a few minutes, and just like the paper mentions, I have a pink-red precipitate. I put the beaker on a hot plate and heated the solution until all of the precipitate redissolved. When it dissolved, I put the hydrochloric acid into the calcium hypochlorite and attached a gas adapter to the top of the flask to bubble the chlorine into the solution. As soon as the chlorine touches the solution, it turns a deep brown and then black. When I was first doing this preparation, I assumed some of the pyridine polymerized and formed tar, but as it turns out, in solution, the ion is a deep brown. I let the chlorine bubble through until I saw that no more of it reacted. After that, I dismantled the generator and let it stand for a bit. Next, I added some water to the black sludge, filtered the product and washed it with cold water a couple of times. The extremely shiny, bright green crystals were then dried on the filter and put into a vial. Thank you for watching. In the next video I'll be making more cobalt complexes, so stay tuned.